Hello? All right. Looks like we're live. Thank you all for coming to my talk. My name is Norman Johansson. I am a principal engineer over at AWS, and I focus on all of the .NET tooling that you probably use building your .NET applications at AWS. This includes the .NET SDK, all of our Lambda libraries out there. I work a lot on our .NET CLI tools, and I help out with our Visual Studios as well. Today we're going to talk about how you can get the performance you need with the .NET SDK. So my goal for you all today is to give you a better understanding of what the SDK is doing. And then you can have that information to decide if you like that default behavior or how you can customize it to meet your needs. So hopefully all of you are going to be able to go back home and take some of these techniques and use it in your applications. Now, I am probably the worst person in PowerPoint. I usually have someone who makes my PowerPoints, but this year we're just going to do a lot of code, so don't expect much when it comes to PowerPoints. But before I do this, I want to make sure you all know what I mean when I say the AWS SDK for .NET, because we have a lot of tooling for you as .NET developers. So when I say the SDK, I am talking about that family of NuGet packages that we have out there called the AWS SDK, or they all have that prefix, AWS SDK. This is where essentially we have a one-to-one. There's a NuGet package for every service. That service has a service client, and it's got an operation for everyone. It's very one-to-one, and it has a very consistent programming model across all of the services. You can see in that little code snippet there on the side, that is the basic usage of the SDK. Here is using Bedrock here. You create the service client. There's a request object you set up, and you call in the appropriate API, passing the request, get back a response. That right there is SDK 101. Probably you all already know this. This is not what we're going to do. This is a 400 level talk. We're going to get deeper today. So the .NET SDK is actually quite old. I've been working on it since basically the beginning, this is its 14th anniversary. So we've had two major versions. We're in version 3 right now, which was released in 2015. We had a slight bump in 2016 when we all moved over to .NET Core. But for the most part, we have tried to keep the SDK very stable, not breaking you much at all. In fact, if you look here, comparing V1 of the SDK to V3, the code is actually very similar. Major difference that you're going to see here is the fact that in V1, we didn't have that concept of credential profiles that maybe you use today. You had to manually load up your credentials. And of course, .NET, we added async await, so now we've added that in there. If you're still using .NET Framework, you still have that synchronous code path. But the takeaway I want you to get is under the covers, we have changed the SDK a lot over the last 14 years, but we've tried really hard to keep that public API as consistent where you can even take code from V1, basically change NuGet packages, and you still would mostly work with minor changes. And that also goes down to even the behavior, the runtime behavior of the SDK. We try really hard not to surprise you with changes in the SDK. And you'll see a theme of that as we go through some of our demos today. Now, I'm going to try to get through all of this. It's going to slam through here. It's a lot of content. I don't know if I'll make it all the way through it, but we're going to give it our best try. So, like I said, this is a demo talk, and we're going to take a break from slides, because you can see how beautiful they are. Those are my best slides, even. OK, so here is, again, this is basically SDK 101. Here you can see we're creating the S3 service client, setting up the request object, and sending that off there. Now, to construct a service client, you actually need two things. You need AWS credentials and a region or endpoint to send the request to. Now, here you can see I'm calling the default constructor, not doing what I just told you, not passing those in there. So by default, the SDK will go and search your environment to try to figure out what credentials to use. Are you running on some compute environment like EC2 or Lambda or ECS? If so, use those attached credentials. If you're running locally, you got environment variables or default profile, it will use those. So this code here is the equivalent, live typing, everyone loves it. If I, oh, nope. Credentials region. So that's really the same thing as what you do when you default constructor, is we have these fallback factories in the SDK that do this whole series of searching for your credentials. Now, the actual construction of the service client, that S3 client, it's actually a pretty small lightweight object. It's just basically yet another object, right? But it's constructing those, searching for those credentials is what can be slow for creating your service client, if you're doing that. So what we highly recommend is that you actually reuse your service clients. You should have one, assuming you're using one account, you should have one service client for the duration of the application. Stick it in your DI containers or whatever you're using, because you don't want to actually resolve those credentials every time. We also, under the covers, inside the SDK, we maintain a little bit of state to make sure that we're kind of tracking the health of the request, if it's working okay, and that can affect our retry behaviors and things like that. So it's, again, another reason why you should share those service clients. And they are thread safe, so it's fine. Just stick it as a singleton in your DI and repurpose to the whole place. So what I mean by that, if we look over here, this guy, this is your standard ASP.NET Core application. Here you can see I'm adding Bedrock using their add AWS service. This extension method comes from our extensions .NET Core setup library, which is our library we have to integrate the SDK service clients with the DI and configuration system. And so what you then obviously would do is inject it in there and use your usual, dependency injection stuff. So that's how you want to basically use that same service client. What I don't want to see you do, and I'm going to come check you, not really, but is something like this, right? Here's an API, right? And on a per request, we're going to go and resolve credentials. Here it's like, hey, debug, go load up my debug profile from that credentials file. What's really bad, and I've seen a few people do this, and it's caused them a lot of problems, is they'll do something like this. On a per request basis, they'll go create this instance profile AWS credentials. What that object does is that's how we go fetch the credentials from EC2. So if you do that on a per request basis, that means on a per request basis, you're making an extra network call to hit this EC2 metadata system to go fetch those credentials. And that might work fine when you're in your development stages and you're not at high scale. But once you start getting to higher scale, that instance metadata service, it can't handle the same throughput as like calling DynaDB. And you're eventually going to start getting some issues about not being able to resolve credentials. So like I said, really do not do that is my big takeaway. If you need to have like a multi-tenancy situation, which is usually why I see people do this, is you need to build something where you're essentially caching either the service clients or those credentials on that per tenancy basis. You don't want to resolve those credentials on a per request basis. Then you'll be calling me up saying, why does this slow? And I'll say, don't do that. So, not that we're calling each other. You'll send me a GitHub issue. That's what it'll be. All right, so let's switch over. Mix the sides up. So, like I said, I'm just going to repeat again. The SDK, we have our fallback factory systems. You can use those yourself or let the SDK use them. But the end result is be sure to cache those service clients. They are thread safe. They're fine to use across the board. So now let's talk about HTTP client. Let's switch back over. So with HTTP client, as you can imagine, that's like the most fundamental piece for our SDK when it comes to .NET. We're web services, right? We're always basically sending parts over. So let's take a look how we use that. Close all that down. I'm going to forget one of these demos to start setup, but we'll give it a try. Oh, here we go. OK. So here's a sample that I told you just not to do, where per iteration, I am going and creating an S3 client and actually making a list buckets call. So I'm going to start Fiddler up so we can kind of see what's going on under the covers. And run this thing. Suspense to do. Now, if we look back at Fiddler, and I know this is small, I'll try to see if I can zoom in here. You can see in that little window there, is essentially we actually only made one HTTP connect call. One time did we actually do that handshake, the TLS negotiation. Even though you see under the covers, I created new service clients, it should be 5 different calls on there. So under the covers, the SDK is keeping a pool of HTTP clients and reusing those. We keep them on it's like per service. So there's a pool for S3, a pool for DynaDB. We use those to make sure that we are reducing how often you are doing that handshake, because that can be one of the slowest issues when making those first requests, is making that handshake. You can actually change this behavior. If you look on the config object, there is a property on there. I don't need caps lock on to disable that off. So to show you what would normally or would happen normally without that, delete that. Going. So now here's what happens if we didn't cache. You can see every time we would be doing the whole negotiation, and that would be really slow for you. Now, generally, I don't have much reason for you ever to turn it off. The only reason I've ever seen anyone have a good reason for turning it off is if they're like running their client application like outside of AWS, and they're maybe making it through a sketchy network, and they just want to make sure that we're always using a clean connection and not something that's gotten stale or something like that. That's about the only reason I would recommend turning it off. But you actually have more control with the SDK on this, on how to use HTTP client. So let's get rid of this. So if you want to completely change how we construct the service clients, maybe you've got advanced use cases, you can go and on our AWS configs, we have a HTTP client factory property, and you can assign a factory to it. So once you do that, any service clients that you create after this point will actually use that factory for creating the service client. So if you look here at my implementation here, basically you have to implement the create method here. And this is where, hey, maybe I want to change some special settings on the socket handler myself. Or maybe I want to add different handlers on there. Or maybe you want to integrate poly down at this level if you're using poly for your circuit breaker. In this example here, I've created an extra handler wrapping around the socket handler just to do some extra debugging, write a line, and I'm actually adding a header on there too. Maybe you're running your application behind some proxy that only lets requests go with a certain headers in there. You can do that with this capability. Now the thing to be careful though here, at this stage of the request process, that HTTP request is considered signed. So if you mutate that request, like changing the request body, the query string parameters, then you're going to get a signature mismatch. Headers you can change because when we sign it, we only sign a few specific headers, and any additional headers are just ignored as far as the signature calculation goes. Okay. So again, did I switch over, or am I am pushing the wrong button. Okay, I would be switching back to slides. I don't know why, there we go. So here again, remember that HTTP client, it might look surprising to you, but under the covers, we are caching those HTTP clients. We do this for performance reasons, as well as there's also some legacy reasons with .NET Framework that we could spend forever on that one. We won't do that. You can turn that off with that switch, but I think what's also more interesting is you can also provide your own custom HTTP factory and do a lot more interesting things at that level if you'd like. Okay, so the next one we're going to talk about is Security Token Service, STS. This is the service that you often use when you want to generate temporary credentials. You often don't use it directly. You often use it indirectly by the fact that maybe your credential profile is set up to do an assume role to another account. So STS is used for that assume roles. It's used for web identity generating into tokens, for SAMLs, things like that. So it has an interesting, surprising behavior for .NET developers that I wanted to show you about. Okay, so here is an application. Here you can see I'm using, not passing in anything, so it's going to use that fallback factory. It's going to find these environment variables. It says I want to use US West 2 as my region, and I want to use my assume role test profile. So this is a profile I set up my credential file that's going to do an assume role. If I go back and start up Fiddler, and run this, I have 4 tables in my account. If we go back to Fiddler, and let's see if we can zoom in again. So you can see there's that request to DynaDB to list the number of tables in there, and that's going off US West 2, but then you can see the call to STS. STS is not going to US West 2. It is going to US East 1. This is the default behavior of the SDK. The reason it does this is, again, that .NET SDK predates when STS was a regionalized service. When STS was first launched, it was only a US East 1 service. Later on, they added regionalization endpoints, and newer SDKs that came out since then default to that. But again, we try really hard not to make changing runtime behavior, and we haven't had a major version since 2015, and so we still default to US East 1. Now, this is going to potentially cause you maybe some longer latency. Maybe you're running all the way in the Australia region or whatever, so you have to go from your region all the way to US East 1, and you're also now relying on the status of 2 different regions for your application that you wanted to be isolated to 1. So you can change that, though, pretty easily, except I'm going to go to my cheat sheet so I don't do something bad in front of everybody. And there's an environment variable you can specify that says for SDS, use regional endpoints. So if I do the same thing that we just did, and return Fiddler on, and now you can see that now we've kept STS in region. We did not leave the region to go to STS. So we don't have a latency cost going over to US East 1, and we are not worried about things happening in other regions, even though our application is working in one spot. So this is one, if we ever do, whenever we do a V4, this will be the new behavior, but we haven't done a V4 in a long time, or we haven't done. So this is one that might not seem obvious to you, and I highly recommend always setting that environment variable, or if I switch back over to slides, this button doesn't seem to like me, so if you guys want to switch to slides for me. You can see you can either set it in the environment variable or in your credential profile. You've got that STS regional endpoint setting you can set in there to make sure that you are using the regional endpoint on there. All right. Now let's talk about retry behavior. So by default, the SDK will try 3, if you get an error on a request, it will retry it 3 times. Except for DynaDB, for legacy regions, we actually retry it 10 times. And it uses exponential backoff between each one of those. Now, we don't retry every error. We retry if it's like an IO exception, you got a throttling error from the service, or the service returned back some sort of 500 error. Then we'll retry those. So I want to show you how the SDK sort of does some of its stuff, though. Okay. So here's a simple little application that is basically just going to have DynaDB service client, and I have on the config, you can change using the max error retry to say how many retries you want. Since DynaDB does 10, I want this to fail faster. I changed it to 3. And basically, this is just going to go and pound the heck out of this service. So I am actually not going to send data. I have a really terrible server here that I've written that all it does is return back 500s. It's got to be probably the worst thing ever written, right? Let's send it to prod. So now if I run this, so now we've got this SDK. I think it's spinning up 10 tasks, and it's just pending those 10 tasks, sending them over to our dummy server, and it's just going to constantly getting failures. And you can see initially it's taking about 10 seconds for each of those things to go through all of the retry behavior. Part of that is also just waiting for .NET throttling of all these task systems, but you can see it's failing. But the SDK is maintaining state inside of it to start realizing nothing's working. And so it eventually will see, and you can see it just happened right there, is this is just an unhealthy system. I should stop bottlenecking the system, and it'll switch over to a fast failure mode. Just stop doing the retries and fail for you. once you resolve the situation, maybe you've got a VPC routing issue, something that's caused these all to fail, you fix those, requests will start working, it'll start realizing, oh, the situation is healthy again, and it will get back to its normal retry behavior. So this is, again, another reason why I highly recommend sharing your service client so we can maintain the state and you can have these types of features. Another thing you can do with retries in the SDK, set this up as startup. So here's an example, and I have this zip codes table. You're going to see a lot of this zip code DynaDB table example here, where I'm just, again, pounding on the system. This is going to go to DynaDB for real, and I'm going to just start this up because it takes a minute to get to where I think is interesting for us. But this is essentially loading up a bunch of zip codes on here, but I'm using a DynaDB table that is terribly under-provisioned. Can't say the word. So it's, of course, going to start getting some throttling errors. Now, it's not going to get them right away because DynaDB is going to say, oh, you're getting a spike. I can handle a spike. But eventually realizing you're not just a spike, this is what you're thinking you can do, and you didn't provision for it. So it's going to start sending us a lot of throttling errors as we start pounding on this thing. And I'm stalling while I'm waiting to get to that point, and on a conference network, and drinking a bit of water. See, that's why you do these demos. So you have some time to drink some water. OK, there we go. Starting to get into failure mode. And you can see once DynaDB realizes you've passed your spike mode, we've got tons of errors, right? Okay, then I've very terribly improved. You should auto-scale your tables or use pay per request. But here, I think I have the read units at like 1 or 2. So you can see really quickly, I'm in the hundreds, 400s of errors here. So something you can do to change this behavior, though, as you can see up here, I set my retries to 3, is we also have this retry mode. So retry mode on the config has 3 different settings. You've got legacy and standard. Those are basically the same. So standard, legacy. I think the differences I recall, as I remember looking the other day, is it's just a slight difference in how we compute the exponential backoff, but they're basically the same. This third one is the interesting one that we're going to talk about. It's adaptive. So I'm going to spin that up again so we can start seeing that. But what adaptive does is essentially it's keeping track of all these throttling errors that you're getting and realizing, oh, you're getting throttling errors. Let's throttle the SDK. Let's slow the SDK to try to match what you actually can get through. So, and this did not go while I did all that talking. That was very sad. So hopefully what we're going to see here in a minute is it's going to, we'll still get some errors. It's not going to, because we have to get some of those errors to start detecting them, but it will slow it down and the rate of errors will be much less on there. It's another drinking opportunity. Going. There we go. So you can see now we're starting to get errors, but not near as much, right? If at this point in the old example, we were quickly in the hundreds, here we're a lot more trying to balance what it is. And maybe if I set the retries back down to 3, probably if I would have set it back, left it at its default of 10, there's a good chance that the adaptive would have adapted within that time. So this is a way, if you're finding yourself like you can't change the provisioning or you want to make sure you're handling that, you can try adaptive to make the SDK sort of match what it actually sees it can actually get through to your service. All right. OK, can you switch back to the slides? OK, so again, retry. You can change the number of retries with that max error property. I see a lot of people, either they change it up, or sometimes a lot of times I see they'll actually set it to 0 because they're building their own retry behavior. A lot of customers, they've invested fully into using something like Poly, and they want that to be their thing, so they don't want the SDK. That's how you can tell the SDK, shut up, just make a request, and I'll handle it. It's just setting that to 0. The SDK will do a fast failure mode when it detects things are failing for you. And again, I'm going to repeat one more time, like a broken horse here, and this is why you want to share your service clients between your application. And you can try that adaptive retry if you find you're getting a lot of throttling errors and you want the SDK to try to match what you're getting. All right. So DynaDB high-level libraries. So the SDK, we've got two different high-level libraries. We've got the document model, which is where you create a document, and it's what you basically store a grab bag of data, store and load that in DynaDB. We have the data model. We also call it the object persistence model. That's where you have .NET types and store and load those inside the system. These are very large, high-level libraries. I could spend a whole session on those. But what I really want to focus in is how you can improve the startup time on those. That's been a contentious issue for many people who've used these libraries. So in this example here, so this is using the document model. So here, basically, it's you load a table up, and we call get item up here. Fun random trivia for you. I've been using Fiddler a lot to see under the covers. Another thing you can do is on the service glance is there's some events you can attach to and actually see what's going on in there. So I'm going to run this, and you're going to see that even though we loaded up item, we actually made two calls on that operation. We did a describe table and a get item call for that zip code in my DynaDB table. Now that describe table is coming right from this load table. The way this high-level library is written is that essentially we need to get the metadata of your table to be able to make those low-level service calls. Now, this describe table can cause you issues. First off, now during startup, I'm making two different operations. The describe table is also a control plane API. It doesn't have the same throttling as the get items and put items on there. You have to remember, this high-level library was actually written before things like Lambda existed. So now you have the case of you've got lots of Lambda execution environments that start up, and they're all doing that describe table. That could cause you a thinking issue. The other sort of architectural problem there is this load table method, it's synchronous, right? But the .NET SDK and .NET Core, or modern .NET, whatever you want to call it, that is only async only. So this code has to do a blocking async call to work. And that can cause you thread starvation depending on your scaling on your application. So I think it was in August, we sent out a new version of this high-level library that allowed you to be able to turn this describe table off. Essentially, what you need to do is instead of us just going to the service and getting the metadata, is you need to give us the metadata. So we have this table builder that you would use that essentially, like you can see, it's got add the hash key, add the range key. You need to give us the metadata of the system. We'll use that instead of getting it from the service. I am not going to try and type that all in front of you all. I'm going to go back to my cheat sheet. And you can see for my example here, I'm saying it's my zip code table. It got some indexes. That's my hash key. I don't have a range key for my situation. And I run that. And no more get item, or no more describe table call. So that gets rid of that, and that can really improve, especially in that Lambda case. Because like I said, this was designed before Lambda existed, and doing that describe table in a Lambda environment has caused a lot of people struggles. So highly recommend switching it over to that. Now the other high-level library we have, right, is our object persistence model. So this is where you create that context object up. You use, I've got a zip codes table. I load that up and get that on there. And that has, again, the same thing. When I call that, that is eventually doing a describe table and get item. So we want to get rid of it there too. So what you can do is on that config of the context object, we have a new property called disable fetching. So that gets rid of that describe table call. But we still need the metadata of your system. That's just, we need it. So we've always had in the ability in our .NET types to add attributes on there, right? So we used to always have these, or we always had these on there, so you could basically help customize the mapping between the metadata we find in DynaDB to what your actual .NET type is. Now, if you disable it, this becomes the source of truth. So we use all those attributes to actually define. So you have to make sure you really define everything in there. You put all your hash keys in there, and that's what we're going to use. And so with that in there, we've got no more describe table, all gone. Now you might find yourself, though, in the situation maybe you aren't the ones that wrote the POCO. came from another team. You don't have access to changing those attributes. So what you can do then is combine what we just talked about in the document model with the context object. So I'm going to go and take this definition out, bring it over here after I create my context object, and on that, I can then register that table definition there. So now I didn't have to change my POCO, but I put the definition here, and that will also be a way how to get rid of the described table calls. Everyone's good? I tell you, you're all good, right? All right. Slides again, please. So again, high-level libraries, highly recommend. This was, get rid of that described table call. This was added to the SDK within the last month or two. It was very recent on there. You can use either that table builder, or if you're using the context, you can use attributes on there. Right. S3 streaming. So this is a common request we've gotten over the years, is people write these web applications, and they're uploading large streams up to their system. Right, so here is, I've got something that, web application that's going to take what I get from the stream and upload it straight to S3 using our transfer utility. I'm going to run this client application to send up the request. It goes, and it goes boom, right? This is what we've heard a lot of people saying, hey, I want to just stream this, but it doesn't work. And that's because S3 requires the content link. We have to know how big of an object on there. And so we expect the stream to be seekable and be able to push it up in there. So again, a couple months ago, we updated the SDK to kind of virtually make it support streaming for us. So I'm going to switch now to a newer version of the SDK. Make sure I save, rebuild, because I just keep messing that part up when I just, and I run that. And now let's send over our requests. You can see now it's actually uploading that up there. So how that worked, because I'm on the .NET team, I'm not on the S3 team. I can't change S3's architecture to no longer need that. So what we did here is, so our transfer utility lives on top of S3, and this is what we've always used to say, oh, you're uploading a small object, just do the regular put object request. You're uploading a large object, then let's switch over to the multi-part API. So now in the newest version, we've added essentially a third state, which is, hey, the stream's not seekable. I don't know how big this is. So what we do is we switch to a multi-part API mode, and what we do is we read that stream in, we essentially buffer it up to a part size. We read up to 5 megs into memory. Once we get that up, then we send that over to S3. So we're basically doing it in 5 meg chunks. So what I want you to really take away, this feature is now there, and it can be very useful, but keep in mind, we are going to use essentially a 5 meg buffer to make this work. So you have to make that trade-off in your application if that's going to work for you. All right, I think we're doing OK on time. Because now we're getting to the big one that takes long. All right, one more time on slides. Actually, a few more times on slides. So again, it was version 202 that came out in August is when we added that feature. So just make sure you're using that version. You don't have to make any code changes. It'll just work for you. But just keep in mind that you are using a 5 meg buffer to make that work. OK, so .NET native AOT. This is going to be our last major subject we're going to talk about today. So the .NET team over at Microsoft, they have been working a lot, .NET 7 and definitely .NET 8, to add .NET or native AOT support with the platform. Native AOT, if you don't know, this is the process of essentially compiling your .NET application into a native executable, a Linux, Mac, Windows executable application. The advantage of native AOT is it can give you a really fast startup time because you're not booting up the .NET runtime anymore in this situation, which for those that are really concerned about their cold start performance in Lambdas, this can be a really big deal. Now, since you're essentially compiling your code, your dependency code, all of the .NET runtime into a native executable, the whole system relies on trimming to keep the size manageable. Now, as great as it is to get that cold start performance, there are some challenges with using native AOT. .NET, we've been using .NET. I've been using it since the 1.0 days, so 20-some years, right? We've built a lot of patterns on using reflection and things like that. So reflection in AOT is limited. You can't just do that reflection off of an unknown object type. In native AOT, all of the types that you're using have to be known at compile time. This means that the community, including AWS, we have to work on updating our libraries to really truly support native AOT. The last problem is it's sort of a logistics problem. It's just sort of a challenge. When you're building wherever you're running your native AOT application, like Lambda, you also have to build it on that same platform. Few of us are probably doing our dev work right on a Linux laptop or anything like that. We're most likely working on a Windows or Mac laptop, but here you have to do it on Linux. We do have some tooling out there at AWS that helps you with that. We can do what's called a container build. We do it in Visual Studio and in the CLI, where essentially we have a Lambda build image. We have one for 6 and 7, and we'll have one for 8, hopefully soonish, where we'll essentially do the compilation inside the container for you on Linux. As well as, I'm sure a lot of your CI systems are under the hood Linux as well. All right. Okay, so here is, again, it's that zip code table that I keep reusing all over the tape, where we're just going to go and essentially load up some zip codes up there. Now, to compile this into native AOT, what you do, let me close some of these windows that I've accumulated here. Oh, that's the dummy server. Is you essentially pass in the MS Builder publish AOT. And that'll say, hey, you can see right there, it's generating native code. The other two switches you can pretty much ignore. I have those on there to help print out some extra diagnostic information that we're going to look at. But it's basically either set in on the command line or in your CS proj file to say publish AOT. Now, the thing to look at, though, is this giant wall of yellow. And I'm not expecting you all to read this. This is the SDK, compiling SDK, and it's saying, hey, the SDK is doing things that are not safe inside native AOT. SDK, as I said, it's 14 years old. We've got lots of fun reflection tricks we do. We do dynamic assembly loading as we talked with STS, things like that. Those things don't work in AOT environment. Now this here, so to work around that, because we've been talking about AOT since .NET 7, is in our Lambda blueprints, we've defaulted them to say the trim mode is set to partial. So what partial means is only trim the assemblies that are marked as trimmable. If it's not marked as trimmable, then you compile the entire thing. Now, the con of that, though, is one, obviously you're including the whole thing. And if we look, this is producing about a 15 meg executable for this application. And this is how Microsoft describes it. If you're getting any trim warnings, that means essentially the behavior of your assembly could change inside an AOT environment. So when you're compiled for AOT, you need to test not just your code, but you also need to really test your dependency codes that have trim warnings to make sure that they aren't changing for you or changing on you in an AOT environment. So you need to do this testing, and you need to do it thoroughly in an AOT environment. So the good news and why I want to brought this up is, again, like just about 2 weeks ago, as part of our support for .NET 8, we just pushed out new version, not this project file, 37300 version of the SDK. So that version, I'll go run the compiler again. So with the 37300 version of the SDK, this is where we added a new target with the SDK. The SDK already has, we have a .NET Framework 3.5, 4.5, Net Standard 2.0, 3.1, and now we've added a .NET 8 target to the SDK. And with that, we've also gone through the SDK and made sure we addressed all of the trim warnings. So now you know, if you got that we're not changing the behavior of it. And it also means that the size here is now went from 15 megs to about 11 megs. Now, I forgot to show you this, but I'll show you the second part of this. So this is a tool I use called Sizoscope. It's done by one of the engineers on the .NET team. It lets me look at some of that diagnostic information that's, those extra flags to kind of analyze the size of things. So by trimming, so I meant to show you this beforehand, but before I did this, the core here was 800K and the DynamoDB here was 700K. And so now you can see the core is shrunk to less than about 500K, and DynamoDB is now just 20K, right? So all those high-level libraries that would normally be in there, they're gone because I'm not using those. And if we look at the models folder, that you can kind of see that's just essentially the get item and anything that's used by that, right? So it really shrinks that down. I think what's also interesting too is because now that it's actually pulling in, it's trimmed the DynamoDB, what we're using, is it can also trim the actual .NET framework even more because it's realizing what parts of core we're not using. Like for example, DynamoDB is a JSON-based service. So it doesn't need an XML parser like some of our other services do. So all that's gone. So I trimmed about a meg out of DynamoDB, from our stuff, but the overall size shrunk by about 5 megs because it's using less stuff now. Now, I said that we addressed all of the issues, the trimming warnings in the version. That does not mean we've made everything work in the SDK. There are some pieces that, because of their history of too much reflection, we have basically marked those as saying they're not supported right now. So for example, the reason why I'm using the low-level, high-level libraries, the DynamoDB high-level libraries do not, they do a lot of reflection. So if I was to take some of that code and pop that into here, you're going to see I'm going to start getting a warning. It looks a little bit over here. You probably can't see that, but essentially what that's telling you is that you are using code that requires unreferenced code. Code not known at compile time. So if you're getting these warnings, this is your sign, don't call it. I have to figure out how to refactor my code in order to not use things. Now the amount of code that we have like this in this case is quite small, but there are a few places and you'll run into those. Now the other major challenge that you will find when you switch to AOT is in our core component, we have what we call optional runtime dependencies. STS is the prime example. STS is used by a lot of our credential providers that are inside core. But we can't have core depend on STS because STS depends on core. We got a fun circular dependency problem there, right? And also, you only need it in a few use cases as well. So we've always had this trick that we do in the SDK where essentially it's like, oh, you're using one of the components of STS. We dynamically load that assembly and call it through that way, which is what you cannot do in native AOT. So to get around that, what we call is a registry, where you can essentially pre-register, you can register with core, these are those dependencies you should use. So what I would do, so just to reiterate here, if I go and I set the profile to be new profile, assume role test. Like that's that same profile used in that other demo, right? If I run this inside Visual Studio, so this is not native AOT when I run here, it's going to give me a warning that says, or an error, I can't find STS. That's how the SDK has worked without being a native AOT. And what you just do to fix that is you just add yourself a dependency on there so that we can dynamically load that assembly. That's there. And it'll all work for us. So that's how you have been using this today. But if I was to go into a native AOT environment, I got to build this again, which gives me a chance to take a water break. There we go. And now if I go run this, it blows up. Blows up really fast because it's native AOT, but it does blow up. Now, it's blowing up, and it's going to give us an error message that says you're missing that runtime dependency. Now, what that error message is, we're trying to make sure we tell you exactly what you do need to fix this, is essentially you need to go register what version of STS to use. To fix that, I'm going to go create my STS client. And then we have Amazon runtime dependency, global registry instance. And then there's these register methods. So this is all of essentially the things that we have that are optional runtime dependencies. So if you get an error, it's going to tell you, hey, you need to register this instance with this register method. So I need to go put STS inside there. And so big font. Okay, so now that should work to do. Yeah. I don't know if we need to really watch me do this again, but essentially, yeah, you can trust me that once I compile this, and now when it gets to that point where it's using that credential prior, these assume roles, it's going to go check that registry first, find that we have that there, and that's going to avoid us having to do any of the assembly loading that we. There we go. It avoids doing the assembly loading that you just can't do in native AOT. Now, I have a Lambda function here that is essentially doing the same thing we just talked about. Takes in as an input a zip code, gives you back the output. I'm going to save you all the excitement of watching me deploy this in every possible permutation, and I'm going to switch back over to slides, if I can get help on that. There we go. So this table kind of shows these are the different permutations you can do with deploying Lambda here with, in .NET 8 today, right? So with .NET 8, you can deploy a self-contained .NET 8 Lambda function. And you see here that cold start performance there is about 3,300 milliseconds. Keep in mind, these are approximations of doing this thing where essentially we have a Lambda function that's making one service call to DynaDB. There's a lot of variations always with cold start, but that's an approximation there. And its deployment bundle size is a 35 meg zip file. If you look at our managed runtime, which is probably what most people here are using for Lambda, that brings your cold start time to 1,900 milliseconds, and much smaller deployment bundle. And when we're working on the .NET 8 runtime, it'll hopefully be out there as soon as we can. But I'm going to bet you that the performance number is going to still be in that same rough ballpark on there. So what gets really interesting is when we switch over to AOT. So without the SDK being trimmed, if you're using the one that came out earlier this month, you can see with .NET 7, it was at about 1,300 milliseconds. And then for .NET 8, it went down to 1,200 milliseconds. This is all, full props to the Microsoft team. That was the work that they did to improve the performance of native AOT there. Nothing that we did. But the golden version here is if you can use native AOT with .NET and using our latest version of the SDK, there you can see that cold start performance is just 950 milliseconds. So doing that is half the time that you're going to get with our managed runtime. So if latency, cold start issues is your biggest concern with using Lambda, then using native AOT is something to really look into to bring that down. Now, I mentioned there are a few things that don't work in the SDK with native AOT. The top two are the most likely things that you're going to care about. Not to say anything bad about the other ones, I just think that those two are the most common, which is the DynaDB high-level libraries and that extensions net core setup. They both do a lot of reflection of things that are not known at compile time. So these things on the list do not mean that we can never make them work. I view this as our 3.7.300 version. This is like what we have. This is our first stake in the ground. We've gone through the SDK. We've annotated everything that needs to be annotated. We fixed it, which was fairly easy to fix. And now it's kind of up to you all to tell us where to go to next. If you need these things, then you need to let us know. This is why I want it. Everything we do is open source. You can go let us know on GitHub, and that can let us prioritize it's time for us to do more investment in this area. You know, like there are things we could do, but they're just not easy. Like we can invest in source generators and things like that. The same thing that Microsoft has been doing with their stuff. We can do those too. We just need you guys to help prioritize that work. So again, recap, if you want to use this, be sure to be using 37300. That, again, I think it was the week before .NET 8 came out. So it's very new. If you're building with native AOT, you want to avoid having any trim warnings. So if you're finding anything from us, let us know. We'll try to get that up. And I don't have a demo on this one, but all of the Lambda libraries, or most all of the Lambda libraries we've gone through, those are the Amazon Lambda NuGet packages. We have gone through those and again added the .NET 8 target and addressed their trim warnings in there as well. So we want to make sure, especially with Lambda, because I think that that's the prime use case, you would use it. We want to make sure you have as smooth of a process on there. You know, the one thing I know that's going to be a little catch up on people is that, you know, those optional runtime dependencies, and so just be aware of having to register that with that global dependencies. You should see an error right away and say, oh, I need to do this, and you just add that one line of code in there. You can add either an instance or you can add a factory to that registry, depending on your use case on that. Okay, we made it through all of it. We covered a lot of platform features and a lot of service features. Hopefully you learned something that you can take back to your teams and help with how you build your applications. I got a few other links there. I know we got some people on our team that did a talk, I think it was yesterday, but it'll be on YouTube, on how to write the production-ready Lambda functions. I know they touched a little bit on AOTs there as well. Again, everything we do is out there on GitHub. We're a very open source friendly team. So if you have feedback, please give it out there. And we have a few channels that we put out some of our .NET blog posts. With that, thank you very much. I'm here all week, and if anyone wants to catch up with me, I would love to hear their use cases on .NET. So feel free to reach out to me, and I would gladly catch up and chat with you. If you like this session, you want sessions like this, please fill out your surveys. I guess if you didn't like it, you could fill it out too. That's all good. I can take it. But thank you all again so much for coming to my talk.